Okay, a question came up this morning in the Chem 7 live session that I ran, and I decided to record the video for this because it's content that we're going to be doing anyways, but it doesn't have anything to do with lesson 2 right now, but we're going to be shifting back into types of reactions. And the question was, what's the difference between a double replacement reaction and one that is a single replacement reaction? So I promised I would make a recording to that and put it on your website and YouTube and also on Teams. But in the process of recording the session this morning, I made a technology glitch and I lost the recording. So I'm going to redo it right now. All right. So what is the difference between a double replacement and a single replacement? Let's start with the double replacement reaction. Basically, if you look closely, and this is one of the reactions that you guys have been working with since August, it's basically the test for lead and the test for iodide. It's also a precipitation reaction, which we learned about precipitation, all right, which we learned about formally just before all this stuff happened and we all ended up at home, and I'll quickly review that in a second. How is this a double replacement? All right, so I'm going to go ahead and circle the two cations that are replacing one another. So the lead is literally going to come over here and replace the potassium. And the potassium is literally going to go over here and replace the lead. So you have the two cations switching places, right? So the potassium is going to be paired up with the nitrate, and the lead is going to be paired up with the iodide. And you can see that in the two products here, where the lead has essentially bonded to the two I's, and the potassium has bonded with the nitrate. All right, so a double replacement reaction is a situation where the two cations are exchanging dance partners. Now, when we talk about precipitation, remember there were three parts to the definition. Part one was that the reaction has to be a double replacement, which I'll just abbreviate as DR. Part two of the definition said that we had to be mixing two ionic solutions, and you can see here that the lead compound has nitrate in it, and we learned our solubility rules, and all nitrates are soluble. So we know that the lead nitrate is a soluble solution. And the Ki here, remember that K is out of group 1A. And we know that all 1A salts, including ammonium salts, are soluble. All right. So part two of this was that we're mixing two ionic solutions, and you can see that that's true. Both of these are aqueous. And then part three of the definition for precipitation was that we formed a new ionic solid. All right, boom, right there. And a new ionic solution. Boom, right there. All right, so we've killed two birds with one stone. Now, there's another example of double replacement, right? There's two of them, two types: neutralization reaction. And the one that we worked with in the laboratory a ton was the reaction between hydrochloric acid and sodium hydroxide to make H2O and NaCl. Okay, now let's see why this is double replacement, because we have the H right here coming over and replacing the Na. And then we have the Na coming over here and replacing the H. All right. And remember, for the neutralizations, this was also a fairly complex definition. Number one, it has to be a double replacement, which we just went through the reason why that is the case. Number two, we have a strong, and I'm going to abbreviate this, strong acid that is combined with strong base. You should have your 6 strong acids memorized and your 5 strong bases. And part 3 was that the reaction forms water and salt. Okay, now let's look at the single replacement. We're going to go to another screen. All right, and single replacement, let me just get this thing defined. Single replacement. All right, and to talk about this, we're going to utilize the following reaction. We have zinc nitrate, aqueous, that's combined with the copper, which is a solid, to form copper nitrate, which is aqueous, plus zinc metal. All right, now let's just analyze this one, and you can see that copper is going to come over here and replace the zinc cation, right? This is a zinc cation, is zinc plus 2. You should have that memorized as part of the triad. All right, so we just have a single metal which is replacing a single cation. And you can see the replacement happened. It's here, right? Because now this is copper plus 2, and it is exchanged places with the zinc. So a single atom is replacing a single cation in this reaction. In class, we learned these are all redox reactions because they involve the exchange of electrons. All right, and you can clearly see that the zinc, because it turns into a metal over here, right here it is, it's turned into a metal, that it has gained 2 electrons in order to do that. So it becomes zinc metal here, and it had to gain 2 electrons to do that, right? It goes to zinc 0. All right, with that, I'm going to conclude the review of types of reactions, and I will post the link on Teams and also on my website.